Join me in welcoming Professor Matt Taylor. He's going to tell us something about some cool ways to assist learning agents with external information. So take it away, Matt.
Cool, thanks. So thank you for those of you who are keeping your cameras on so I can see a few people so I don't just feel like I'm talking to a blank screen. I appreciate it, yeah. So I'm being selfish again. I'm gonna tell you about some stuff that I think is really interesting in the hopes of convincing some other people that they should also be thinking about some of this, as well as trying to solicit feedback from you guys. So as we know, DeepRL is awesome. It's mostly in games, and sample complexity can be awful. So I like to pick on OpenAI 5. But I've talked about this before. So I've been thinking about how do we get more RL solutions deployed? And back in April, I gave a talk on challenges of real-world reinforcement learning, where I talked about, how can we identify RL problems? How do we de-risk them? How do we solve them? And today I want to talk about something a little different, more thinking about how do we cheat? So my understanding of Rich's view is that everything is the environment, and the agent should just be able to act with the environment. There aren't privileged actors. There's not privileged information. And I want to push back against that, saying that if we want to solve a problem today, then I want to cheat in every way possible. I want to bias the heck out of this agent and provide it extra information so that exploration doesn't take so long, so that I can get to a good policy quickly. So some of the things I want to talk about today are looking at transfer learning, where we can leverage an existing agent to learn faster on a different task or with a different agent. Off-policy learning, which people in this audience are much more expert than I am, and also getting help from. So getting help from another agent, getting help from another program or another human. So before I go into any of these, I do want to admit that, okay, if we're incorporating this kind of knowledge, then we are absolutely biasing our agents. We really want our agents to learn novel solutions. We are not using reinforcement learning to save time on programming. It's not that I have come up with the best way of trading stocks and I am just too lazy to write all that down. No, it's that I don't know the right thing. But I probably have some information that could help that agent learn. So should we be thinking, so I'm kind of thinking of this as if I'm providing this extra information to an agent, in some sense it's kind of cheating. So it's good for short-term fixes, but like Rich argues in the bitter lesson, that maybe this is causing long-term damage by not focusing on the core RL problems. We should be figuring out how to make our algorithms faster and more data efficient, rather than figuring out how to have humans help them. And I'm going to argue that there are situations where it's absolutely worth doing this, especially if we can show that we're not harming our asymptotic performance. Granted, we're almost never going to reach it, but if we can show that suboptimal humans don't prevent us from reaching the optimal performance of the limit, that may be good enough. So this is the diagram that I came up with in 2012, and it's kind of been directing my research since then. So thinking about how a human can teach an agent, how an agent can help an agent, and how an agent can help a human. So that's kind of the inspiration for the research I've been doing. So the first example I want to talk about is transfer learning. So this was stuff I started working on in 2004, where you can take one agent and then use it to speed up learning for a different agent or in a different task. These days, the cool kids call it policy distillation, and say that transfer learning didn't start until deep learning, but it can go by many names. So if you have access to the agent's brains, if you can get the Q value from the source agent, if you can get the neural network weights from the source agent, if the source and target tasks are similar enough, you can probably transfer and improve things. Also, often the source agent needs to be reinforcement learning based. Sometimes it needs to have a similar function approximator. There's various levels of how flexible these methods are. But one of the real problems is you often need to carefully design a curriculum. So if I have this one task I care about, fully autonomous driving, an expert or maybe even a layperson could come up with a sequence of easier tasks that an agent could learn leading up to that. And you're able to learn that entire sequence faster than just training on the final task. But that takes a lot of human involvement. So some people have been working on automatic curriculum learning. So that's one thing that's particularly exciting. If we could generate these curriculums automatically, that could make transfer learning much more widely applicable. The second thing I wanted to mention is off-policy learning. So this is just a data set. So this data is telling us something about how the environment works. So this data could be generated by an agent, it could be generated by a person, it could be generated by a human. So for instance, going back to my favorite example, if I'm doing stock trading, if I want an RL agent to learn how to trade stocks, it ought to use some existing data because we've been trading stocks for a long time, especially if we thought the environment was stationary. This is really true when we think of using machine learning to improve existing processes. It may not be true if we are innovating and coming up with a completely new thing that we couldn't do before, and only through machine learning can we now accomplish it. But the things that I don't understand, and hopefully some other people in the audience can help me understand, is I don't have a good grasp around how good the data needs to be, or how stochastic the behavior policy would be, or how different can the learned policy be from the behavior policy before things go wonky. So we're doing a little investigation just so that my student and I can try to better understand what's going on, how this works. And I was really inspired by Scott Neekham's talk, where he was talking about offline policy evaluation, where you can say, I am 95% certain that my policy will at least receive a reward of something if I deploy it right now. So that was pretty exciting. If I could go to someone like AltaML and say, okay, we're going to implement an off-policy RL algorithm, and then you can tell the customer, here's how well it's going to do with this confidence. Do you think that's good enough that we could deploy it? So that was exciting. There's also the question of not just evaluating a policy, but also improving it, right? It makes sense that you want to learn the best policy you can. And also in Scott's recent talk, he mentioned how you can actually change the behavior policy to better learn that target policy. So running the target policy online is not necessarily the fastest way to improve it. Instead, there's a behavior policy that can improve it faster. Okay, so with that, what am I thinking about? Hugger and I have started a project where we're trying to understand when and how to deploy a policy after off-policy learning. So the simplest thing is just saying, okay, I'm getting a bunch of data, and I want to turn off the program, the hand-coded program that's generating this data, and I want to turn on my RL agent and act online. When am I sure enough? So how does my appetite for risk factor in how long I want to use this hand-coded agent, which probably can be outperformed by an RL policy? Second question is, going back to stock trading, suppose I am paying someone to trade stocks for me. How does this change things? Because now, not only do I need to evaluate when is my learned off policy better, but maybe it doesn't have to be better. Maybe it just needs to be close, because that way I can stop paying this guy to manage my money. Another thing you could think about is, can we influence the behavior policy in ways it's safe? So for instance, if I am trying to learn off-policy driving, and I say, hey, behavior policy, it would be super useful for me if you could show me what happens when you crash into a tree. something in that system better say, no, the value of information is not worth that. And so I only recently heard the term value of information. I mean, I think I've heard of it before, but use it in a context of machine learning. So thank you to James Wright for bringing that up, because this is now my key phrase that I need to better understand. So figuring out how do we measure estimate the impact of learning something in the long term versus any short-term costs. So I'm really interested in hearing from you all about off-policy learning because I'm very new to this. The third topic I wanted to talk about, and this one goes into a few more details, is thinking about how an agent or a person could help. So we can ask something, what should I do? And it's likely suboptimal, especially if it's a person. But if I'm doing a control problem, maybe I have a PID controller, and I can just ask that PID, what action would you take now? So it doesn't, there's not necessarily a sentience or a cognitive framework for this, but maybe that is useful. So some things we've looked at are things like, oh, one thing I forgot to mention. When we are doing this, we don't only want to use machine learning geeks. So when people were doing learning from demonstration with robots, it was common to use other students in the lab. Turns out when you take a normal person and try to teach a robot, you get different results than if you take a roboticist and try to change a robot. You know, in retrospect, it's obvious, but this is something that we need to think about. What is the quality of the advice we're getting? So we could think of getting demonstrations. So someone can teleoperate a robot. You could give action advice. Pac-Man go up, Pac-Man go down. You could give feedback. Oh, sorry, I forgot I put all these cool pictures in. So teleoperation, giving advice, and also feedback. So good robot, bad robot. You should be able to teach a robot like you teach a dog. DeepMind did some cool work on Hopper learning to do a backflip by just giving trajectories. Show two trajectories, and the person picks the one they like better. And there's other things like giving high-level advice via English. There are other ways of providing help. So there's lots of different ways of helping. One of the interesting questions to me is who is going to initiate this? So the teacher, I'm assuming, has more knowledge, especially at the beginning of learning, than this student. So the teacher might know when it's important to provide this kind of advice or interaction. But on the other hand, many methods assume that the teacher cannot see into the student's head and does not know the weights of the neural network of the student. So it could be that the student knows better when to ask. Maybe the student is very confused, and that would be a good time to ask for help. And Ofra and others looked at that, how you actually combine them. So what I'm particularly interested in this case is thinking about using explainability in terms of getting help. So it seems like explainability in RL is part of this human teacher on the side or human on the side. So helping the human to decide which agent do I want to use. Can I predict how an agent would act? Or in this particular context, if the teacher can better understand the student through explanations, can the teacher provide better information? So either knowing when to interrupt and provide some advice, or even what to provide. Because there are cases where providing the optimal policy is not the best thing to teach. So for instance, if agents acting randomly, you could either try to get the agent to learn this policy that's decent, or you could get the agent to learn this, like in Cliff World, you get the agent to learn this really high-performing policy that's right on the edge of the cliff. And anytime that student makes any wrong move, it falls off the cliff. That's probably not the first policy you want to teach. I'll also mention Britt and I are thinking about, can humans spot fake explanations? So our hypothesis is that if I give someone a saliency map, they can come up with an explanation for why it makes sense, even if it's random. So we can think about when one type of help or advice might be preferred over another. So for instance, I can give feedback. A helicopter crashing is bad. A helicopter managing to hover is good, but I cannot teleoperate a helicopter. I do not have that ability. So thinking about users' preferences and competence, but you can also think about what if the help isn't unlimited? What if there is a total budget? I can ask for help 100 times. So we did some work at Borealis with Leno, where we have an ensemble that is a learning ensemble over Q values. And we can use this ensemble to estimate uncertainty. If the agent is very uncertain, that's a good time to ask for help. And you want to set the threshold so that the student generally stops asking for help on its own before the budget is exhausted. So this is a very simple heuristic method that actually worked quite well. So there could be a budget. There could also be an explicit cost for asking to help. So thinking about when I am trying to maximize my portfolio and I have to go and pay someone for their time to analyze my portfolio. So with James and Amir, we're looking at when should I ask for help? So the simple case is I'm in a multi-arm bandit. I'm on my last pull. Should I, oh, and there's a teacher that can tell me the exact payoff of one arm at some cost. Should I just pull the arm with the highest expected payout? Or should I ask and then pull the arm that I now know is the best? Maybe it changes, maybe it doesn't. And another thing we've been thinking about is, what if I am collecting rewards or units of utility on the bandit, and then the teacher is charging me in dollars? Now we're comparing apples and oranges. So now it's kind of a multi-objective problem. So how do you answer this? Whoops, you think about the value of information. So James, Amir, and I are working to try to understand what value of information means in this context. So we can also think of, well, what if there are multiple teachers? So I've got one guy who could speed run in Mario, one guy who's good at collecting coins in Mario. Who do I want to ask? Maybe they have different costs. Maybe someone who's not very good at Mario charges less. How do I decide who to ask? Value of information. Or I could think about, what if there are multiple students? So you could think of, I've got a teacher that stands on the side as a coach and could decide to help the team, or maybe one agent. Or I could have someone who's actually playing on the field and learning, and maybe they can only interact with the people around them. So that's what Sahir and I have been bouncing around, where the teaching doesn't have an explicit cost. But if I'm teaching agent A, then I'm not helping agent B. Similarly, if I'm giving team level general advice, I am not providing targeted advice to the goalkeeper who's making some mistake. And we can think about what happens if the teacher can only communicate locally, or if the teacher is learning. And this is kind of an implicit value of information calculation. So the last thing I want to mention is, what if we have a trained RL agent and a novice human? So this is absolutely related to intelligent tutoring systems. And here we're looking at sequential decision processes. So not just teaching addition, but having to teach a sequence. And could we do this automatically? Could we do this for video games? So with Levi and Fatima, we are looking at how do we help humans. We're looking at Levi's game, The Witness, and trying to figure out, first condition is I have a human who's just learning on their own. Then I want to figure out, can advice help? Well, if it doesn't, then this project is not going anywhere. But we're pretty confident some advice will help more than just letting a human fumble around. The next question then is, what's the difference between student-initiated advice versus teacher-initiated? How can we figure out when one will work better or why? And we're also really interested in productive failure. So thinking about, maybe I let the person mess around for 5 minutes and then let them ask for help for 2 minutes. Then they mess around on their own for 5 minutes, and then I provide them help, that kind of setting. So I'm really excited about trying to show that we can use agents to try to teach these kinds of sequential decision processes. And part of that's going to be making sure we're not duplicating existing literature in education or ITS communities. So last slide, I'm trying to argue that, well, hopefully I've convinced you that using external information can be interesting and can be exciting. I would be interested in hearing, is this putting me at risk or my group at risk of having to relearn our own bitter lesson? If you had examples or ideas for other types of external information we should be using. If other people are also thinking about value of information stuff, I'd love to hear it. Of course, if you have suggestions or related work, please send them my way. I'm hoping this will start a conversation with some more people in the department, and we're always open to collaborations. So if this sounds cool, please don't hesitate to reach out. All right, and with that, I will turn it over to questions.
Thank you, Matt. Can you hear me?
Yes. There
Hey.
Bob.
Hey, Matt. Yeah, I agree with you that, oh, my cat is fleeing. I have to come back in a minute.
Easiest question to answer ever.
Okay, my wife got it. So my comment would be that I agree with you that we should work together, and that you call cheating, I think it should be seen as giving a head start to the agent, right? It's not all that we are going to do. That's not what you're claiming anyway, right?
That's correct.
So now, one comment I have about the comment you made about deployment is that I think we are being a little bit conservative about the deployment. Why can't we just look at like how deployment is actually done regarding, say, non-learning agents? What people do there? Do they look for like guarantees? Like they need to know absolutely how things should work before they deploy? Is that what they do? I don't think so. Like in many cases, that's not what they look for, right?
But there are standard QA processes which
Exactly.
have not necessarily been modified to apply to situations like reinforcement learning, especially if you're allowing the agent to learn online.
Yeah, so there is a process for deploying, and it's not the being sure 100% or having some guarantee before deployment is not the only way. I think for reinforcement learning, we are thinking that way is because we are kind of not sure about our technology. We don't have much confidence on it. It shows our lack of confidence on our technology. That's why we want to be 100% sure. Other things that get deployed, they have many different ways, such as like in the end, the best way is to deploy and see. Now, obviously, you don't want to do that massively. So there are things like canary release. You do it for a small percentage of all deployments so that you get some sense of it, right? So that's the truest way, I think, to understand how it works. And
yeah,
we can also have that way for our agents. Yeah, go ahead.
And that's absolutely appropriate in some cases, but in something like healthcare, you really don't have that kind of margin for error.
I agree with that. So if regarding that, I have another comment, which is that, again, I think we don't have enough confidence on our technology. And that's also a societal thing, as well as probably deficiency regarding our own technology. And that can be gained probably by first deploying our agents in applications where we have that kind of margin, so that we gain some confidence. And then from other areas, people learn about our technology. Oh, it works in this area. We might have some more confidence now deploying in a more difficult areas. That might be a real way we'd be able to have some reinforcement learning applications rather than probably trying it on an area where we don't have enough margin and we are looking for guarantee, which I'm not sure how in the end practically we can achieve.
But is that fair entirely to say that we don't look for guarantees? Like if I put on my classical control hat, they do spend a lot of time looking for guarantees in their methods. And I think, I mean,
Absolutely agree. Yeah.
yeah.
Go ahead.
So,
No, you're right. All I said is that that's not the only thing, the only way. That's not the essential and necessary part of all deployments.
sure, I agree with that.
That's all. So we have to be more creative, probably, because it's becoming so challenging for applying that we are resorting to cheating justifiably. We should resort to other creative ways as well.
Patrick, what did you mean by warm start by domain and not just by expertise?
So I'm just trying to clarify what Ram was saying. And I was reading it as that there are domains that allow us to warm start our agents and our agents' expertise that are more or less suitable, as opposed to, say, choosing or pinning a domain and then selecting the right kind of external expertise or the right kinds of cheats. You can essentially cheat by scaffolding the environments. And I kind of thought that's what Rupam was pitching, is that you build a scaffolded process of more or less risky domains to move towards your deployment case, as opposed to, say, like the work with Levy in the witness, looking at scaffolding human learning towards competency in a single style of domain. But maybe the witness is a bad example because the puzzles are so diverse. But anyway, I was just trying to clarify what Rupam was thinking.
That's a great way. Including the ways that Matt mentioned. We have to look for more ways that we can win.
Catching domains, Rupam, is this your approach? It's like you let the cat out and then try and catch it? This is the new natural domain?
Yeah. So we build this fence and we are trying to see whether they stay. So they explored the backyard for a whole month. Now one of the cats is kind of done exploring. Now they are like, it's inevitable that they have to go out.
We have 3 minutes left. That's easily a time for one more question or comment or criticism.
So, could you guys hear me?
Yes.
Good, good. I never know when I talk on these computer things, but you know, this bitter lesson. You know, I think there is a risk that we'll learn a bitter lesson again. I think of it very much in the same way that Patrick has to run this risk, and you know. But the way to minimize the risk is sort of what you're doing, which is to.
I just lost Rich. I can't hear him anymore. Patrick can't hear Rich either. I can see Chaba if Rich is not able to connect to audio.
No, I was just about to say that I can't hear Rich either.
Oh, I thought you were going to solve my value of information problem.
Well, I have some comments, but well, I don't know. Like, I've been thinking about that for quite some time in the context of bandit problems and beyond, where you really have some trade-off between value and action. And we had some ideas just this year which could be useful. So I just wanted to talk to you privately about that. But at the same time, I also wanted to warn everyone against like just believing in that words solve all problems. So just because we put a label on it, like value of information, doesn't mean that we did anything, right? Like sometimes these phrases are so empty because they can mean so many different things, and then they mean different things for different people. It's like, yeah, it's kind of unfortunate that sometimes the words don't serve their purpose anymore. But having said that, there are some ways that it's also related to POMD problems, and you can easily run into computational hardness, and then that's my biggest concern when thinking about these problems of how do we avoid the hard cases. Like, what are the modeling assumptions that are gonna save the day? And yeah, I don't know. It's a very good topic. So Rich is trying to make lemonade.
So we are out of time right now, so I completely understand if people want to drop off, but I'd really like to hear Patrick say something about this.
How do I avoid the bitter lesson?
You're doing stuff with people, man.
Dylan says, what does going meta mean? Okay. Alex, do you want to go and ask questions instead?
I mean, I just want to, the more meta you go, I don't know what meta means in this context.
I think that we're gonna end. Oh, I can't say that. I wanted to point to some literature. Okay, let me make a positive spin on it. Like, there are examples in the literature when people go really meta. They even prove things about really meta to the point that everything becomes uncomputable. You know what I'm talking about. So don't do that. Just don't go that far. I'm okay going more meta, but
the right amount of meta, not too meta.
Not too meta. Yeah. I think meta, I do have, but I don't know whether people want to hear what I think about meta. Maybe we should hear what Matt thinks about meta. Yeah.
Nothing. I don't understand the context here. I'm waiting to talk to Rich or Patrick later.
Oh, no, I mean, like, I can explain.
Okay, explain.
And I don't know why Patrick is not explaining it, though. Patrick, you should explain. Come on, like, you have mic, no? Okay, cool.
I feel poorly placed to explain without further thought, so please carry on discussion. By context, I dropped a cell phone on my own toe and maybe broke it yesterday, so I'm lacking a lot of sleep. So I'm not the sharpest tack in the box today, but I'll crunch through it. If I come around, I will chip in a second.
Okay. Wow, that was interesting. So, you know, there is this idea of that you want to learn the learning algorithm, and then maybe learn the learning algorithm that learns the learning algorithm, and then you can go like further up. And so then you might wonder about, like, does this even make sense? Like, why do you want to do this? And I see that there are reasons to do this. And it goes back actually what Matt was saying. So there are cases when our best tool to express some of our biases is through posing computational problems to the computer. And that's exactly what we're doing in this meta learning. Like, you're feeding it with data. We can feed it with data. We know, like, how to generate the data that is relevant, that is describing the biases in the word. But we don't have the mathematical model. We don't, like, know how to, you know, change the search algorithm and whatnot, right? But you can still play with the data. So I think that that's the big idea behind meta learning, that you can express a lot of implicit knowledge by, you know, feeding the computer algorithms with the right data and leave it to the computer to figure out the rest. And it's a useful tool. I think it, as everything, it has limits, but it has not been explored as much as many of the other things. So it's like in the hands of someone who can really, you know, like, you have to have access to big compute, have to be good at optimization. It is very useful, and it's like, it's an orthogonal direction to everything else that you can do. So it's complementary. It's not like that you do this or you do that. You can do both. So I think that that's the meta, and like the idea of a meta. I don't know about that, because my head just explodes if I try to think about that. But I mean, by induction, you can make it transfinitely inductive, and like, okay, like, I don't know, then stop. Okay. at transfinite induction, maybe you stop this meta learning. Or just do one meta. Okay, so okay, Rich, that saves me. I'm thinking about this really hard problem of how to do transfinite induction and meta learning, but okay, Matt,
right.
what do you say about this?
It sounds interesting. I don't think I'm the right person to push RL in this meta direction.
Not yet, maybe.
Okay, so since
followed into the meta business,
since we are 6 minutes over, I think I'm going to call it. But I really appreciate the feedback and the questions. If you have more ideas or want to talk to us or me, please just reach out. Always happy to chat about this. Thanks, everyone.
Thank you, Matt. Let's thank the speaker.
Yeah, thank you.